Okay, we are back for the second video from section 3.2. In the first video, we talked about the first two ways that you can use to solve a quadratic equation, and both of those could only work in certain circumstances. But if those circumstances are met, you want to use one of those two. So just a quick review. For method 1, if there's no b term, you solve for x squared, and then take the square root of both sides. And then for method 2, you're going to use that when you can factor. Now, I should say when you can factor easily. So if factoring's not your thing, you may have to do it occasionally because, we do want you to learn it. So there might be homework or even on a test that you're going to be asked to use factoring to solve. But if this isn't your forte, on the ones where you're just asked to solve and you have any method available to you, you could skip this. You will get the right answer if you use one of these last three methods. I should say the next two, because the third one, the very last one, the number 5, can sometimes doesn't give you an actual exact answer. So I'll get to that. I'm kind of getting ahead of myself. Okay, so if you can factor easily, do method number 2. Okay, method number 3. It is called completing the square. Oops, I scrolled just a little too far. There we go. And this is probably the one I use the least. In fact, I use this only whenever I have to, but I think it's a good way to kind of understand why the next method, which is the quadratic formula, works. So you're kind of like recreating the quadratic formula whenever you do completing the square. So I think it's a fun one for exercise, or maybe fun's not the right word, but I think it's a good one to know as an exercise, and you will need to know how to do it for homework, but it's not something that I feel like is real important going forward. So we're going to do an example here, practice it on homework. You will not have to do this for a test or quiz. Okay, and like I said, this is the one it's not my go-to. My go-to is the others. Okay, so let's just do it by example. We'll go through, there's 4 steps listed here. We're just going to use the example down here and just go step 1, 2, 3, 4. Okay, the first thing that it says is move the constant to the right side of the equation, but if it doesn't say this, but if there's anything else that needs to be moved to the left, you put everything else on the left side. So the constant is the term that does not have a variable, so that's the 9. The x squared and the minus 8 we leave on the left. And I didn't say this, but you need to leave a space before the equal sign. And since it was a positive 9, when we subtract it over to the other side, we're going to have a negative 9 over on the right. So x squared minus 8x, leave a space. That's important. Sometimes I'll even draw a blank. I'm going to fill that blank in my next step. So leave a space equals negative 9, and then we're going to leave a space over there as well. Okay, step 1 is done. Step 2 says determine the value c needed for the left side to be a square and add it to both sides. And it gives you a formula here. C is going to be equal to b over 2, the whole thing squared. And what is b? B is our, if you go back up to the very top of the page, b is the coefficient of the x, the number in front of the x. So b in this problem is negative 8. So out here to the side, I'm just going to write c equals, I'm going to replace the b with negative 8 over 2 squared. Well, negative 8 divided by 2 is 4 squared, or negative 4. And once I square it, I get positive 16. Negative times a negative is a positive. So that is what goes in the blank. Determine the value c needed on the left side to become a square. And we use that formula, so we're just going to put plus 16. Now we know from any time we're solving equations, what happens if we add 16 to the left side? What else do we need to do? We need to add 16 to the right side, and that's why I put a blank over here as well. So once we figure out c, we're going to add it to both sides. And on the right-hand side, we can actually do that. 16 minus 9 is a positive 7. On the left side, and we're now down to step 3, rewrite the left side as a square. Okay, so we've done step 1, we've done step 2, and if you've done step 2 correctly, for this next step, you are going to be all set up and ready to rewrite the left side as a square. And what we're talking about there is we're going to rewrite it as a binomial that when you take it times itself, you get that trinomial. So again, this is kind of going back to review of factoring. So if you're struggling with this, make sure you do that review of factoring. So a binomial square, we purposely picked the 16 so that it works. You take the square root of the first term, square root of the last term, and then you take the sine of the middle term. And that's going to be squared to go back up to the original. So let's just check that. I'm going to do this up at the top of the page. I'm going to check that x minus 4 squared is equal to what we want it to be. So x minus 4 squared means x minus 4 times x minus 4. So we have a FOIL. First times first is x squared. Outside is x times negative 4, or negative 4x. Inside is also negative 4x, and last times last is negative 4 times negative 4, which is 16. We can combine the two middle terms, and we get exactly what we said we should. X squared minus 8x plus 16, and we purposely picked that 16 over here where we calculated the c. If you do that little calculation correctly, this is going to work. So square root of the first term, the sine of the middle term, square root of the last term. That's what the binomial is going to be. Now we can go back and apply method number 1. Method number 1 that we learned in the last video was to take the square root of both sides, but now instead of having x squared on the left side, we have something else squared. We're going to take the square root of that, which basically means we get rid of the square root sign, or the square sign. The square root of x minus 4 squared is just x minus 4. And then we take the square root of the right, but we need to remember to put plus or minus in front of it, just like we did when we did method 1 on the first page. So we have one last step to solve for x. We need to add the 4 to both sides, and we get x equals 4 plus or minus square root of 7. We check, can we simplify square root of 7? No, it's not a perfect square. It's not a product of perfect squares. So this is our answer. If we are asked to give an exact answer, then what's written down here is what the answer is, 4 plus or minus the square root of 7. But if on the other hand, if you're asked to give it as a decimal, and just like we did on the first page, we're going to look at what if it, decimal, M-A-L, what if you are asked to round it to the nearest thousandth. So again, thousandths means 3 decimal places, so we're going to do that calculation, and I'm going to pull up the graphing calculator to do that. And you can see I already did the first one. So 4 plus the square root of 7, so that's our first answer, is 6.64575. If we're rounding it to 3 decimal places, that 5 is going to become a 6, because the next number, let me pull that back up, that next number is a 7, so it pushes the 5 up to a 6. And now let's do 4 minus the square root of 7. This is 2 different numbers. Anytime you see that plus or minus, just realize that's a shorthand for 2 different numbers. And we hit enter, and we get 1.35, and that's going to round to a 4. So be careful. This is probably one of the things I saw the most on the test when I was looking at your actual work versus what my math lab was looking for. You would miss a problem because it told you to give an exact answer, which means it wants you to still have the square root in there, or it wants you to round. These are not exact. Once you put it in your calculator, it's not exact anymore. It is a rounded answer, and I saw it both ways, where my math lab asked you for an exact, but you gave a decimal, or it said round, but you put it in as the square root. And of course, my math lab only checks to see if you did exactly what it was looking for. And in that case, you did get some partial credit. I also saw a few times when your rounding was off. So if it says thousandth, it's 3 decimal places. If it says 100th, it's 2 decimal places. Tens is 1. So make sure you know that. Read the problems carefully, especially on a test, because you're losing points if if you type it in wrong. And I do go back and look at partial credit, but you don't get full credit. It's always best to do it the 100% right. Take your time and read how you're supposed to put your answers in. Okay, I'll get off my little soapbox for that. Let's go on to the quadratic equation or quadratic formula. This is method number 4. Like I said, method 3, which is completing the square, I really don't use in real life because I think it's a lot of steps, but I think it's an interesting one to understand why the quadratic formula works. You're going to see some of those same numbers show up whenever you do a problem with the quadratic formula. Quadratic formula is a formula that will always work. So if you remember, the first 2 methods we learned only worked in certain situations. Method 3 and method 4 always work. And both of them will give you an exact answer. You notice they have that square root in there. So if you're asked to give an exact answer, you're going to want to make sure you kind of go through if method number 1 works, use that. If method number 2 works, use that. Otherwise, jump down to method 4. I really don't use method 3. If I was just asked to do one and given all of my options, I would skip on to step number 4 or method 4. Okay, so we're going to use this formula, and this is still based on our basic ax squared plus bx plus c equals 0. So our coefficient for x is a, coefficient of x squared is a, coefficient of x is b, and the constant is c. So before we can work this example problem, we have to get it into the right format. And it's awfully close, but notice that constant is over on the right-hand side. We don't have the equals 0. So we need to subtract 1 from both sides, and that leaves us with 2x squared minus 3x minus 1 equals 0. And from that, we can determine what a, b, and c are. And I just like to write that out just so that I don't have to think as I am applying the formula. I have it all written out, and when it's time to grab a, I can just grab it from the list. Time to grab B or C, and I think about negatives because that's one of the things that can mess you up here. Make sure that you include whatever sign is with that coefficient. So A is positive, so it is the number 2. B is the coefficient of x, which is negative 3, and then C is negative 1. And now I plug it into the quadratic formula, and I get x equals negative b. Well, b is negative 3. So what is negative 3? Would just be 3. Negative b, or I'm sorry, square root of b squared, and b is negative 3. So negative 3 squared would be 9. Negative 3 times negative 3. Minus 4 times a times c. 4 is 4. A is 2. So 4 times 2 is 8. Times c is negative 1. So that whole thing becomes negative 8, but it's minus that product. So it's negative 8 or positive 8. And then in the denominator, 2 times a is 2. 2 times a is 4. And now we simplify. And this is some of those same things that have been popping up that are kind of assumed when you come into this class that you know. My square root just was kind of extending past there, so I wanted to redraw it, which is simplifying equations like this. And so we want to start underneath the square root. We need to take 9 plus 8. You can't take the square root until you have just a single number under the square root, and that's going to be 17. Can we simplify that square root? No, we can't. You can go through and check. Is it a perfect square? No. Can you divide it by a perfect square? So let's think about that. The first perfect square is 4. Does 17 divide by 4 evenly? No. The next perfect square is 9. Nope, doesn't work. And then we jump up. 4 squared is 16. You can't, 17 divided by 16 does not come out even. And then it goes past at 25. So we know we've checked everything if you've checked all the perfect squares that are less than 17. And then just to add the other side, if you're asked to write the decimal equivalent or the rounded, the approximate using rounding, I just wrote the answers there, 1.781 and negative 0.281. Remember, there's 2 answers, one with the plus square root of 17 and one with the minus. So you can plug that into your calculator and check. I'm just going to pull up my calculator screen and show you that. One thing I wanted you to note is, notice on these last two, these are the actual two answers here at the bottom. Notice that I did a parenthesis to close the 17, the square root of 17, because whenever you hit the square root sign, it automatically starts a parenthesis. And then you have to do a second parenthesis to say, okay, that's everything that's going to be divided by 4. You know, that's our numerator of our fraction. Right above here, notice I left a parenthesis out. I said 3 minus square root of, and there's a parenthesis. That one is automatic. And then I did close parenthesis divided by 4. What it happened up here is it only took the square root of 17 divided by 4 because I don't have a parenthesis that captures that 3 with the square root of 17. So notice the answer did not come out right. So be very careful. If you have an open parenthesis, make sure you have the closed parenthesis that goes with it. In this case, it was to put everything in the numerator that needs to go together in the numerator. Okay, let's, for this next section, we're going to be looking, and I highlighted here, what's under the square root. We're going to be thinking about what happens when that is different values. And if you remember what we've talked about with square roots before, if what's under the square root is positive, we're going to get two real numbers, right? Square root of a positive number. It might not come out even, like the 17. It didn't come out even, but it gave us a real answer. Square root of 4 is 4. Square root of 5 is the square root of 5. If what's under that square root is a positive number, we're going to get a real answer for the square root of it. And then right in front of that, we have a plus or minus. So we're actually going to get two answers whenever what's under the square root is positive. You guys with me? We're going to write all this down at the top of the next page, but I just wanted to talk through it with you first. What if what's under the square root is 0? What will our answer look like? If what's under the square root is 0, this whole thing just goes away because it's taking the square root of 0. So we end up with negative b plus or minus 0 over 2a, or just negative b over 2a, right? And then what if b squared minus 4a is negative? That does happen sometimes. What if it's negative? Then we're going to be taking the square root of a negative number. And from our last section, 3.1, what does a square root of a negative number? Well, that's when we bring in our imaginary numbers, because the square root of a negative 1 is I, and then we would deal with everything else and figure out if we could simplify the square root of what's left. But that would give us an imaginary answer. So we have three possibilities here. What's under there is going to be positive, or 0, or negative. And because that's such an important thing, that really plays into what our answers are, we have named what's under the square root the discriminant. So the discriminant, what goes in the blank here, of a quadratic equation is b minus 4ac. Notice that that is under the square root in the quadratic formula. That should say under the square root in the quadratic formula. You can write that all out with the stylus. It's a little tricky. Okay. And it can be used to determine the number of zeros, the number and the kind of zeros. Okay, so the discriminant is b minus 4ac, and it can be used to determine, just like we saw on that previous page, the number of the zeros, also whether they're real or not, right? We talked about that. So let's just go through. This is exactly what we just said. If the discriminant is 0, in other words, if what's under the square root is 0, that whole thing goes away, and we just get negative b over 2a, because the plus or minus square root all goes away. So what do we have in that case? We have one answer, one solution, and it is going to be real because it's just negative b over 2a, so that is one real solution. Okay? And so I guess you could change the verb there to is instead of are. Then there is one real solution. Okay, the second possibility is that what's under there is positive, greater than 0. If it's positive, you're going to have plus or minus the square root of a positive number. Square roots of positive numbers are real. And since we have the plus or minus, it is two real solutions. And finally, if it's negative, then we have plus or minus the square root of a negative number, and that is two imaginary solutions. So for one solution, we just end up with negative b over 2a. That's a single solution. The other two, we have negative b plus or minus the whole thing, b squared minus 4ac. And if the b squared, I left the squared off there, sorry. B squared minus 4ac. Let me make sure I didn't leave that off when I wrote the formula down. No, I didn't. Okay, let's go ahead and do a couple examples. Now notice that in these two examples, you're not asked to solve them. You're only asked how many real solutions. So this is just looking at that discriminant to determine how many real solutions. So the first thing we need to do is we need to put these in standard form, which means we need to have ax squared plus bx plus c. So the negative, or the 8x needs to be subtracted over, and the negative 5. So I get 4x squared minus 8x when I bring that over to the left. And then I'm going to add 5 to both sides, so I'll get plus 5 equals 0. So a is 4, b is negative 8, and c is 5. So my discriminant, which is b squared minus 4ac, right up here at the top of the page, is going to be negative 8 squared. Negative 8 times itself is going to be a positive 64, minus 4 times a is 4, so that's 16, times 5 is 80, and that was positive, so it is minus that, and we get negative 16, which is less than 0. So I look up here, there are two imaginary numbers. Now notice that this asks for how many real, not how many solutions. How many real? We only have 2 solutions, but they're both imaginary, so there's no real solutions, or the answer is 0. How many? 0. Okay, let's look at the second one. Same thing, we need to get everything into standard form first. I need to subtract that 11 over. So I always want to start with everything on one side equal to 0. A, B, C. 5 is A, negative 4 is B, negative 11 is C. And so I do b squared minus 4ac. B is negative 4, so that's going to be 16, minus 4 times A was 5, so that's 20, times 11 is going to be negative 220. And so I end up, and since 4ac was negative 220, but it's a minus negative 220, that's going to be plus 220. And so I end up with 26. It's a positive number. And so I go back up here to my list. 2, if it's positive, I'm going to have how many real? 2. Okay, so that's how you do those using the discriminant. Okay, I'm going to stop here because we're over 20 minutes. I was going to try to do graphing in the same video, but I'll put graphing and that very last topic in video number 3.